Hello everyone, today we're going to learn how to do limiting and excess reactants. Now with limiting and excess reactants, the biggest problem that I consistently see students having is not approaching this in an organized and methodical manner. It's really easy to forget what you're doing and why you were doing it, and what useful information you actually found. So the biggest thing I recommend is label what you're doing. It will help. Now when addressing these, the first thing you need to do is look at your chemical equation and make sure it is balanced. If this is not balanced, everything else you do will be wrong. And you don't want to get to the end of the problem only to find out it wasn't balanced when you started. That's not a good feeling. So let's check to see if this is balanced. You have 2Na on the left, 2Na on the right, 2Cl on the left, and 2Cl on the right. This is balanced. The next thing you need to do is find the molar mass of your reactants and products. And I strongly recommend writing these down and circling them or boxing them or doing them in a different color. For Na, the mass, or the molar mass per mole, is going to be 22.99 grams. For Cl2, that's going to be 2 times the weight of Cl, or the mass of Cl, and that comes out to be about 70.90 grams. For NaCl, you add the weights of Na and Cl together, and you get 58.44 grams. And you can find all of this information on your periodic table. So put a box around this, label it as molar mass. You will need this information later. Now the question is asking us which reactant is in excess and which one is limiting. In order to figure that out, we're going to have to do two separate equations. Now there are two different ways you can solve this problem, but I only teach one, and that's the product method. I think it's faster, it's easier, and it gives you more useful information. I recommend finding whichever method works for you and sticking with it. Don't try to learn two, you'll just confuse yourself. Stick with one. So the objective here is to find out how much NaCl is produced. So let's write that down. Objective. Find how much NaCl is produced. Because these equations can be a little bit long, it's good to write down what you want to do and why. So the first thing we're going to do is compare sodium. We're going to have to do this twice since we have two reactants. So let's start with sodium. We want to find how many grams of NaCl it can produce. So we're told that we start with 16.933 grams of Na. Now be sure to keep track of your units here because they're actually super useful. They can seem like a pain at times, but they help you catch any mistakes you make. Now when we compare stuff to other stuff, we need to do it in moles. We can't do it in grams. So here we look back at our lovely molar mass table that we found beforehand. And we know that for every 1 mole of Na, we have 22.99 grams of Na. And now, looking back at our lovely balanced equation, we compare the stoichiometric coefficients. We know we need 2 moles of Na to produce 2 moles of NaCl, our product. So for every 2 moles of Na, we produce 2 moles of NaCl. Now I recommend taking this one step further and putting it into grams. It will be useful later. For every 1 mole of NaCl, we look back at our lovely table, we know that it weighs 58.44 grams. Now we go back and we cancel our units. Make sure we did this correctly. Grams of Na cancel, moles of Na cancel, moles of NaCl cancel, leaving us in grams of NaCl. Sorry, these are moles of NaCl that cancel. And that equals, let's break out our calculator. If you look here and you're feeling clever, cancel out the 2's. 2 divided by 2 is just 1. That'll save you some time with typing. So we have 16.933 grams, or 16.933 times 58.44, and that is going to be divided by 22.99. And that gives us 43.04 grams of NaCl. Now what you're going to do here is that you're going to label what you just did, and that's product from Na. That's what you get for a product, or the amount of product you get if you use Na as your reactant that you're comparing. Now we have to do this again with Cl2, because that's our other reactant. And we're going to do the exact same thing. We're told that we'll start with 19.273 grams of Cl2. So 19.273 grams of Cl2. Now that I've gotten you started, I want you to pause the video and try finishing it on your own. Now that you're going to go, let's do a walkthrough and see how you did. Again, we need everything in moles. So for every 1 mole of Cl2, you look back at your lovely table and see that it weighs 70.90 grams for Cl2. Scroll back up to your balanced equation. You see for every 1 mole, there's an implied 1 there, of Cl2, you produce 2 moles of NaCl. So for every 1 mole Cl2, you produce 2 moles of NaCl. We want to know the weight in grams. So for every 1 mole of NaCl, look back at your lovely table, see that it weighs 58.44 grams. Now go back through and cancel. Canceling is your best friend. Grams of Cl2 cancel, moles of Cl2 cancel, moles of NaCl cancel, and you're left in grams of NaCl, which is what you wanted. So get out your calculator and do the math. 19.273 times 2 times 58.44 is going to be divided by 70.90. And that gives you 31.77 grams of NaCl. Now you go back and you label what you just did. Product from Cl2. And you circle it. Circle it, highlight it, mark it up somehow so that you can find it and know what it is that you did, what it means. Now the question originally asked us, what reactant is in excess and which one is limiting? Now the limiting reactant is always going to be the one that gives you the smaller answer. You have 2 answers. One is a good one is a meaningless one. And the good answer is always the one that's smaller, since that's the amount we can actually make. The bigger one is a lie. We cannot actually make that much. But we didn't know that this answer was a bad answer until we compared both. So look back down here. We got 31.77 grams of NaCl from Cl2. So Cl2 limits what we can make, so Cl2 is limiting. So mark it here. Limiting. by the process of elimination, we know that Na must be excess. Now we have a second problem down here. How much product can be theoretically made from the starting amounts provided? And the nice part about this question is we just answered it. Look back at the amount of product made from our limiting reactant, Cl2. This is the amount that can theoretically be made. So this one is done. Question 3. How much in grams of each reactant remains at the end of the reaction? So here we had two reactants. We had Na and Cl2. With Cl2, which is our limiting one, think of it this way. If I had money and then I used up or spent all my money, how much do I have left? I have none. Same with Cl2. If this is our limiting reactant, that means that all got used up. And if you use up everything, you have nothing. If you have nothing, you have 0 grams of Cl2. So half of this is done. For Na, it requires a little bit more work. And we're going to need the stuff that we previously found. So let's go back up here. We're going to copy our molar mass table down, because that will be useful to us. Drag that down. And we're going to copy down the amount of product we made from NaCl. Oops, I don't want that 3 there. There we go. Erase that bit. And this is product made. And we need this information to figure out how much we used up. So we started with some amount of NaCl. We go back up here, we started with 16.933 grams. So 16.933 grams of Na is what we started with. Next, we need to figure out how much we used up and how much is left over. So our new objective is to find the amount used up. And to do that, we're going to compare the amount of product we made to the amount of reactant needed. So we know we made 31.77 grams of NaCl. As with everything, you need to compare this in moles. Now I want you to try pausing this part and trying it for yourself. Okay, let's see how you did. For NaCl, we know that for every 1 mole of NaCl, it weighs 58.44 grams. Be sure to mark down what it's grams or moles of, otherwise this could get really confusing. Oops. If you look back at our lovely balanced equation, we see that we needed 2 moles of Na to produce 2 moles of NaCl. Scroll back down. For every 2 moles of NaCl, we need 2 moles of Na. Now we need to convert that back into grams. For every 1 mole of Na, we look back at our lovely table. See, this is why making this table is a fantastic idea. It makes things so much easier, you don't have to go back and relook it up. For every 1 mole of Na, it weighs 22.99 grams. And now we do the math. So we have 31.77 times 2 times 22.99, and all of that is going to be divided by 58.44 times 2. And we get 12 point, and if you round that up, end up being 12.50 grams of Na used. Now I want you to take a second to stop and look at this answer. Does this seem reasonable? Compare that to how much you started with. If you find that you used up more than you originally started with, that means something's gone wrong with your math. You need to go back and double check. This is a good way to catch errors. Now, we're going to circle this, and this is amount of Na used up. This is why we did this. So here, we know we used up 12.50 grams of Na. Now the last part, you just find the difference between the two. Let's do it down here. I started with 16.933 grams of Na. I used up 12.50 grams of Na. If we subtract these two things, we will get the amount that's left over. So 16.933 minus 2.50 gives us 14.43 grams of Na, and that is what's left over. So we have 4.43 grams of Na left over and 0 grams of CO2 left over. This part, done. Now there's one more thing you can do with this information. Let's say you're in the lab and you did this reaction. If 25.267 grams of NaCl was experimentally formed, what is the percentage yield of the reaction? So let's go back to see how much we originally found. In here, we're going to do experimental over theoretical. And make that into percent form, we're going to times it by 100. So we have our experimental amount that we went to the lab, we weighed it out, and we found it was 25.267 grams of NaCl. Let's scroll back up and let's see. This was the amount that we originally made, or the amount we made theoretically. If everything went perfectly, this is the amount that we should get. In real life, if you scroll back up here, the answer would still be there. However, this is on a computer. So theoretically, we should have 31.77 grams of NaCl. We're going to divide those two and times it by 100. And there are plenty of reasons why this could be different. Maybe your reaction didn't go through to completion, or didn't fully go through. Maybe you weighed stuff out wrong. Maybe you spilled something in the lab. Stuff happens. Either way, we're going to figure out our theoretical yield. So we have 25.267 divided by 31.77 times 100. And that gives you 79.53% theoretical yield. And this does not have units because your grams of NaCl cancel. We do not have any more problems. Good job, guys. Keep on practicing this, and don't forget to label what you're doing. It really is helpful. I'll see you guys in class.